Hello, I'm Brett Lusser, Business Development Sales Manager here at Harrington Hoist, and welcome to Lessons on Lifting.
Hi folks, I'm Greg Butler from the Product Support Department here at Harrington Engineering. Today we're going to talk about the HBB code on our drives. The under the cover VFD on Harrington ER2 and MR2 style hoists and trolleys has proven to be very reliable, but occasionally we do get calls, and the most common of those calls is, hey, my hoist has an H66. Well, actually, it's HBB. It stands for Hardware Base Block, and that code means that the VFD is not getting a signal from the e-stop button on the pendant. We'll start by making sure the e-stop button is released, and to do that, you just rotate it counterclockwise or clockwise, and it should pop out. The e-stop button's released. We still have the HBB, which means that we're not getting that signal to the interface board that the e-stop is released. So all good electrical diagnosis should start with a wiring diagram. Inside the cover of our hoist is a wiring diagram, and we're going to go over that right now and discuss how the circuit works so that we can better understand how to troubleshoot it. Power comes out of the secondary side of the transformer and goes to CN13, which is a 2-pin connector on the interface board. It has a black and a gray wire in it. From there it goes to fuse 1 on the interface board. If the fuse is good, voltage continues on to CN11, which is a white 6-pin connector labeled CN11 on the interface board. From there it travels to the 8P plug on the side of the hoist. From the 8P plug down to the pendant. That wire's black. Inside the pendant, if the e-stop button has been released, it closes the switch, and voltage then goes on a green wire back to the 8P plug. Many people call and say, hey, where's this? You got a short in your pendant. You got power going to this green wire. The green wire is not a ground in the standard ER2, MR2 pendant. It sends control voltage back to pin 5 on CN11, which then goes to relay 11, RY11, also labeled on the interface board. When the contacts close in RY11, we complete the H1 to HC circuit on the VFD, and the HBB code goes away. Okay, so since our e-stop button was released, we know we must have some other type of problem. To begin troubleshooting, we're going to check and make sure we have control voltage coming out of the transformer. To do that, we will make sure, number one, that our meter is set to read AC voltage. We'll connect to a good ground, and we're going to check and make sure that we have control voltage on CN13 on the black wire. Right there we have 124.8 volts. You might be asking, well, how do I know what control voltage should be? Control voltage on all of our products, standard, is 110 volts. But you can get 48 or 24 volt control. So listed on each of our transformers, it's going to tell us what the output voltage is, 105 to 119.4 volts. So we know we have 110 volt control. All right, we do have 110 volts, so we know that the transformer is good. From the wiring diagram, we know that the voltage goes from CN13 to the fuse on the interface board. The fuse is a little difficult to get to. All right, so basically an easier way to test that is to go to pin 4 on CN11. The power goes from CN13 through the fuse and comes to this black wire on CN11. So at CN11, We'll stick our probe down in there. Be very careful when you're back probing these things that you don't back probe the wrong wire. Make sure that your jumper pin or your back probe is not shorted against anything else. So we back probe that pin and we see 125 volts. All right, we know the fuse is good. If you don't have 125 volts there or 110 volts, you need to back up and find out, is the fuse blown? And if the fuse is blown, why is it blown? Is the pendant cable cut somewhere? Is it shorted? Find and correct that problem, replace the fuse, and the HBB should go away. Since we had control voltage there, we know from the wiring diagram it leaves pin 4 here, goes down to the pendant, through the E-stop, comes back up to pin 5. All right, so we're going to check and make sure we have control voltage on pin 5. That will verify that whole part of the circuit. Pin 5, we have 125 volts. That's good. We know that the circuit's working. We can also test the E-stop while we're here. With the E-stop button pushed, we're down to millivolts, okay, 200 millivolts. Basically, it's an open circuit. With the button released, we have 124.8 volts. All right, so now we know that that's all good. The next step is to verify that the relay on the interface board is good. And RY11, it's the center relay on the interface board. And what you're going to want to do is just look in there, and as you push and release the E-stop button, you should hear it click, and you should see the contact points open and close. If those contact points are not opening and closing, and we did have control voltage, then you need an interface board. Okay? It's that simple. The relay's not serviceable, it's not replaceable, you need an interface board. If the relay does work, we're going to move to CN12, which is the output from the interface board to the VFD. So, real simple, we just want to make sure that the connector is fully seated and engaged with the interface board. This one is. We're going to say that looks good. So the next step is to go to the VFD itself. Take that cover off. Take that cover off. Be aware the VFD is hot. Okay, the unit's plugged in. We do have 460 or 230 volts here, so be careful where you're poking around. Take that little sticker off. Want to make sure that our wires are tight here. HC and H1 are what's connected to the VFD. Everything looks good here. Starting to look like maybe we have a bad VFD. So, what we're going to want to do is shut off power to the drive, lock out, tag out the hoist, and we're going to install a jumper between HC and H1. If you install the jumper and the HBB code goes away, the problem is not with the drive. You need to back up in your troubleshooting. You missed something. Okay? There's an open wire. There's not control voltage. We thought we had it. If the code goes away with the jumper, it's not the VFD. If you install the jumper between HC and H1 and the code's still there, then you need a VFD.
That completes this segment of Lessons on Lifting, and thank you for joining the revolution.